Next week, Wednesday, at this time, we are going to have the first exercise lab. At that time, to accommodate all the students, we decide to use the bring on your device, okay? So before you come to here, so why don't you download the virtual machine, which is instructed on the class, the project description, exercise lab document. So if you go to the Canvas, then the file, then you can find the folder for the exercise lab. Then open the file, then see the link where you can download the virtual machine. I think is there anyone who download already? How long it takes?
10 minutes.
Yeah, 10 minutes. But if you try to download here, I don't think it will work well. So please download at your home before you come to here. Then also you need to install the either VirtualDub or the VM player. Then I don't think I didn't test the whole the VM player, but most of the popular VM player will work with that virtual machine. Okay, so then we will have an exercise lab in this room. So at that time you don't have to connect the database, but just in case, why don't you download the PDF file also? Then you can see, you don't have to print out all the document. If you want to, you can do that, but sometimes waste of your money and the paper. So just the download on your laptop, then you can see it together with your virtual machine. Any question? Okay, then from time to time we have the quiz. If that is a scheduled quiz, I do not remind or announce. Okay, you need to check the course schedule on Canvas. Then whenever you need, you need to submit it. But sometimes, if I cannot cover all the topic that is required for the quiz at the time, we will extend the due date or the shift to the later. Okay. But I'm not going to remind every time, so it's your responsibility to check and submit your the quiz and any other activity. Any question? Okay, so we are going to move forward. So last class we have talked about the general, the idea of the computer and the operating system. We will see the basic the concept and the structure of the computer and operating system today. So this is what we have discussed before. And the computer system basically consists of the hardware. So operating system need what for what? Between hardware and the user, we need the operating system. So operating system can be considered as the group of system programming that can handle, that can manage and coordinate the computer resources. However, it is true if we have the unlimited resource of the computing power, like the unlimited power of the CPU, unlimited the size of the memory, and the unlimited infinite fast speed, then actually our operating system will be very, very simple. Okay, we can just assign whenever we need the computer resource from the user, then we can assign such a computer resource to the computing power to the user or application. Unfortunately, we have a very limited the computer power. Are you satisfied with your computer or your cell phone? Oh yes, it's good. But I don't satisfy with even I purchased this one the last semester. Sometimes it's not very fast. Not faster than I expect. That doesn't mean it's getting slower, the hardware, in terms of hardware. This is something, the issues to coordinate and arrange the computer resources. So even though the computing power increased exponentially, but still that cannot follow the user expectation. Okay, so because of that, we need operating system. So operating system is in between hardware and the user. And also that hardware mostly the three part it's not the class of the computer architecture, but everybody I believe know that there's processor, memory, and I/O device that we discussed over here the last class, right? Why don't you remind that? And also user doesn't have users don't have to be the human being. It can be other program, other computer resources, or anything others. Okay, that the request, the service of the computing power. Then in between we have the operating system. So operating system is a group or set of the software. Don't forget, operating system nothing special. It's just a software. You can implement it. So throughout the semester, especially in the exercise lab, we will test something basic, the system programming. So if that works very well and very important as a new idea, you can add that system programming as a part of operating system. It's the operating system. Okay, it's not very special thing. It's not rocket science. It's just a group of software. And also even I developed a new device hardware then to utilize, to use that, the new device, you need the software, like the firmware, the program, so that can be considered as even operating system. So nowadays, so some people, some of the students just consider operating system only the Windows 10 or the Linux system or the very popular operating system, but that's not true. The operating system, still many of the manufacturer company, they need the expertise on operating system who can do schedule for specific device and the requirement. So it's, I believe the operating system programming is one of the very bright area for your future career. Then one more thing, in addition to hardware and the user in between the operating system, we need the application program. I don't have to mention about the application program because you have the developed and tested and trained to develop such an application program. Example, Microsoft product is an application program. Internet Explorer is an application program. And also, this is the second class of the day. So I have the back-to-back class. In the morning, I taught the database. What about the database? Database management system. So what do you know about the database?
Stores important information.
Yeah. So for example, Oracle, MySQL, SQL Server. So where it belongs to? Hardware, operating system, application, user, database even? It's an application program. Because of that, so sometimes the student ask me, I know some of the students would like to be a database expertise or a database programmer, so administrator, how can I prepare to be a database or something? Study operating system. That's more important because it's running on top of the operating system. So without understanding the operating system, you cannot understand how the application program is running. Okay, so that's the category of the component of the computer system. We are going to focus on this operating system part, especially for the algorithm, and I'm going to try to a little bit more the implementation and practical experience of the operating system. That doesn't mean we are going to build a new operating system. I don't think so. It's practically possible. Instead, in your project, in your exercise lab, we will partially implement the part of operating system, component of the operating system. For example, project A will in project A you will implement shell program. Shell is one of part of operating system. In the second project you will implement portable file system. It's a part of the IO device management. Okay, in the exercise lab you will test some very basic the system programming, like the creating process. Okay, so creating process is one of the important tasks of the operating system also. Okay. So this is the slide that describes the overview of the 4 components in the computer system. So right now you may understand where the operating system resides on. Just here. Then, what operating system can do? We have discussed a lot, right? So operating system provide what?
Combination with hardware and
Interface between hardware and the user, right? So that's the one important thing. What else? What else? I mentioned just before. we have the limited computer resource, right? The user requested that service. But if you let the user use any, no matter how much the computer resource they want, just let it use, no, you cannot manage your system properly. So you need to control and coordinate, okay, such a computer resource, because we have the very limited computer resource power. So user want something better performance, more the computer resource, but in your operating system you need to manage such a thing. So sometimes all operating system call the resource allocator, okay? Not just the interface, you need to coordinate. You need to allocate computer resource power properly to the user, okay? And also control that program. What happens if a process is malfunctioned? So that can hold a lot of computer resource. During that time, the other process, the other application cannot access, so cannot utilize such the computer resource. So you need to control, like here, such a process and manage such a program. Okay, so how can we define the definition of the operating system? It's not easy, because as we discussed the last time, somebody consider operating system as what? Just the first process, kernel module as an operating system. On the other hand, some people believe operating system is everything. For example, when you purchase the Windows 10, you are purchasing the operating system. Then they send all even application program. So somebody believe the operating system is everything shipped to the computer. So for me, so it's okay no matter what definition you use, but anyway, it is true. It starts from the kernel, just the first program running on. Okay, so especially for the system programmer who develop the operating system, like for example Linux system, you can add the functionality or module to the kernel and rebuild the kernel and release it. That's operating system. That's the starting point. And also, if you have the commercialized operating system and add, like the Microsoft would like to add a lot of application program to their operating system, okay? Such as the internet browser. So right now the Windows 10 use the Edge. Actually, Edge is the application program, but they intentionally add because it's a kind of the very important interface between user and the Microsoft. So that is the macro view of the operating system, but I believe it can be understood as everything, operating system. So I like this definition when we define what is an operating system. So an operating system is a program that control and coordinate the use of a hardware resource. So control and coordinate the resource. Because of that, we need a lot of algorithms to satisfy this condition, this definition, like the CPU scheduling algorithm, memory management algorithm, or the disk scheduling algorithm, something like that. If we don't have to control and coordinate, we don't need such an algorithm, then our operating system will be very, very simple. But because of that, we need to study throughout the semester such an algorithm, and you should be able to implement it. Then, so we have the three main parts of resource, control, and coordination. Okay. So from now on, we are going to quickly review and overview of the computer architecture and operating system. So if you can understand properly today's lecture and next week the lecture, it will cover most of the things that we are going to discuss throughout the semester. Okay, so first, based on the small definition of the operating system is a kernel. The operating system regarded as a kernel, the first program when the system is starting up. At that time, the bootstrap, the virus program, In other words, a firmware. Anyway, the computer device, the computer system is also the mechanical device. It needs the software, the firmware software, so that can be considered as a bootstrap program. So bootstrap program is part of the, can be considered as the part of the operating system. Okay. Then you, I think that we can skip the computer system organization. I believe that you guys already know about the computer organization. But one more thing I'd like to know. What is a controller, disk controller here? So you know the I/O devices and the monitor, and these are the I/O devices and memory, and we have the CPU. Then, as you can, CPU is over here. You can see something controller, and adapter. So what is a controller? Why don't you remind your computing architecture class, what is a controller? A person who controls. Memory?
Grammar.
Grammar?
Grammar.
Grabber?
I/O device. I/O device.
I/O device. Yes, they are I/O devices. Then all I/O devices are connected to certain controller. So anyway, CPU need to communicate with these I/O devices, right? They cannot directly communicate. Why? Why? So speed gap. So we need memory, which means through the memory, CPU need to communicate each and every I/O devices. How? They are devices, which means it's they send the information, digitize the information. Are they use the same information? No, definitely not. The disk uses something, and the USB uses something. Even USB 1, USB 2, USB 3, they are using different the data structure. Monitor use a different one. VGA, or the nowadays this one is VGA, and HDMI. They are using that. How CPU understand each and every different
Through controller.
through the controller. So controller has what? It's a device that has program. It's kind of firmware program, device program. So long time ago, when I purchased a hard disk drive, 100 megabyte hard disk drive, it was very, very expensive. Then at that time, when I connect the hard disk drive to the computer, actually my computer cannot recognize it. Because that hardware, new device, the hard disk drive use different data structure, which my operating system cannot understand. Then I need to install what?
Driver.
The driver device program. Okay? So driver is a software that can be installed in this controller, then finally used through the driver program, your operating system can understand such a data. Nowadays you don't have to. Why? Actually there exists, but first reason, many of them are standardized, like the universal bus, USB. And another thing is, operating system actually include all such a device program. Okay? So, for example, when the Microsoft actually, it's so surprising. So if you go to the company, so even small company who develop the hard disk drive or whatever, they have the roadmap of the operating system. Microsoft usually announce the 10 years, 20 years roadmap. Okay? We are going to announce the Windows 11, 12, or whatever new version in 2020, 2015. Then each company manufacturer, if that is verified, then Microsoft will include on their operating system. Then sometimes you may not realize. So when you purchase the device, I/O devices, you don't have to. Okay? Okay, that is also part of operating system sometimes in broad view. Then this device, when they communicate each other from the CPU through the memory, sometimes CPU need the data from the disk drive and get the while they are retrieving the data, CPU need to wait. It's a waste of CPU time. So CPU need to get the input from the monitor or the mouse, keyboard, and process other. Then suddenly the disk hard disk drive finally get the data and would like to return to here. Then how do they communicate? How do they know? I retrieve the data, please retrieve this data, and I need the input from the monitor or the mouse. How? At that time, they have one very smart way for communication. That's called interrupt. So interrupt means, what is an interrupt? So for example, while I'm lecturing, so he has a question, okay? He can interrupt me by raising hand. Then if I allow, he can ask a question, or even he can do whatever he wants. So interrupt me. It's the same thing. So computer, as I said, is a limited resource. So I don't want to wait. The CPU doesn't want to wait until the data is returned. Instead, let it go. Perform the other. But in case of something done, this controller need to inform to the CPU, I'm done, so I'm ready to send back the data to the CPU. Then at the time, send the interrupt signal, then CPU will stop. Then get the data, something like that. Also, when you send the data to the other device, I/O device, yes, send the interrupt signal to send it. So that is a reason nowadays a modernized operating system, modern operating system is an interrupt-based operating system. So in your microprocessor class, so you or the microprocessor or the embedded system class, you implement such an interrupt signal. So operating system should be able to handle such an interrupt signal. So that is the device controlling from the CPU based on the interrupt. There are different types of interrupt. Did you take the microprocessor class? What types of interrupt do you have?
Maskable.
Trap. Trap? Yes.
Maskable and non-maskable.
Maskable, non-maskable is another thing. First, as he mentioned, trap. So trap is type of interrupt. So basically, there are two types of interrupt. One is hardware. Hardware send the signal to the CPU. Hardware receive the interrupt signal. So hardware-based interrupt. So interrupt is nothing but signal. I need something, I ready, something like that. So at that time, we can use some of the function, some of the memory area or the interrupt vector to change the value. So 0 means it's a yes, the no interrupt, and 1 means it's there is an interrupt, something like that. Who send such an interrupt? Who change the value? Hardware. So hardware interrupt is the most popular one. Okay. Another types of the interrupt is software based. Why? Even operating system need to interrupt the I/O devices. So operating system can send such an interrupt signal. It's a software based. We have two types of the interrupt. One is hardware, another one is software. Even software based, in your application program, you can interrupt. When you wanna use the hardware, like this data or something other exceptional case, you can use such an interrupt signal. For example, in Java, or the programming exception, you can use the exception. Like the most popular such an exception is divide by 0. computer cannot handle the divide by 0. It will be the infinite number value. So in case divide by 0, you need to inform to your computer interrupt, then this cannot be done. Then return the signal to the user or the program. How can you catch such a case? Using exception. So exception is the kind of software interrupt signal which is called thread. It looks like the thread. So you make the exception in your class. Then the in case divide by 0 or the in case something happen, then out of that module, okay, you can interrupt. That is called the thread. So we have the 3 different types of the interrupt we can use in operating system. One is the hardware and software. When we are saying the software is mostly operating system programming level. But also we can have the thread. Thread is the application program level, software level, like the exception case. So to catch whether there exists the interrupt signal or not, we can use a polling. Okay, polling is keep checking certain value. Okay, keep checking, or the vector. So we in the memory we have the specific area, the address. So this area will be used for the interrupt. So we have the different types of the interrupt signal. So in INT0, INT1, INT2, something like that. Some of them are built-in when the manufacturer developed the CPU processor. The others user define. You can define the interrupt signal. So that you have probably learned in the microprocessor class, the built-in interrupt signal. So we are not going to see the details of the interrupt, which one is which one is which, but we will see a little bit more in the later during the I/O management. Okay. So these are the definition of the interrupt and thread. So there are 3 types of the interrupt that we discussed. So that's the interrupt used in the current operating system. Okay, so that is the interrupt-based operating system. Then the operating system has the I/O structure, I/O, so we will see the I/O structure, memory structure, and just the overview of the operating system as well as the computing architecture. Okay. I think that we already discussed it here. System call. So CPU and memory, in addition to the CPU and memory, all the other devices can be considered as the I/O devices. So that is the reason the operating system consists of the 3 main parts: the process management for the processor, and the memory management, and I/O devices. Then, how can we use such a computer with I/O devices or even process? At that time, we can use the function or system API. That is called the system call. Okay, system call means it's a kind of the built-in in the operating system, built-in the API, system API to create the process. There's a function. So you don't have to implement very, very low-level assembly language programming. Instead, the operating system provides the function, system API. So you can just call the for or exec function. That is the system call. So for example, I'd like to read the data from the hard disk drive through the disk controller. At that time, you can call the system call that read the data. It's a read. If you want to write the data to the hard disk drive, it's already implemented in the operating system. Write the system call. Depending on the operating system, it's a little bit different. Like the Windows has their own system API, system call, and on the other hand, the Linux has their own. Even the same Linux version, even the Linux, but depending on the types of operating system, like the Debian, CentOS, or the Ubuntu, they use slightly different the system call. How many? roughly 200 to the 250 system call. Using that one, you can do whatever you want. Okay? What about the Java programming? I didn't use any system code in my Java program to create the new process. No, I can just initiate the instance, the object file, or I can use the Java thread. Then how you can create the new process, how you can access the file in the file system. How did you do that? Java is a high-level language. They already implement a certain function in the compiler. Okay, so they have used a lot of such as system call, but using system call is a little bit difficult for the end user. So instead, they hide the such a system call system function. Instead, they make their own method API. Okay, make it easier and flexible. So that is the reason it's called a high-level language. In the exercise lab, we will test several basic system code to get used. Okay, if you are using such a system code in your programming, that is called system programming or Unix programming. If you implement if we are using Unix system code, so nowadays still there are a lot of job opportunity who require system programming. I realized that most of my students who graduate this program are very well for the application programming. How to use the Java function or Java API or .NET environment and fancy nice the interface, but sometimes lack of the system programming, which are required sometimes when you get a job around the IT. So why don't you think about that to improve your, it's not very difficult, even sometimes easier than the very fancy. For me, I'm not very good at the fancy, nice graphical user interface to design. Instead, system programming, if you know how operating system working and the requirement, the system programming is sometimes easier than such a complicated application. Also, mostly the system programming is much simpler, shorter. The length of the source code is shorter than the application program. The next, storage structure. What is a storage? So in operating system, we have the CPU and memory and the I/O devices. Among them, what is the storage? Storage is where we store the data, right? Where we can store the data? Hard disk, right?
Memory.
That's it. Memory is also storage.
Register.
Register is another very fast, smallest storage. Okay. Also, nowadays even the CPU, the vendor, they provide the L2 cache, another storage area to speed up. So we have certain hierarchy of the storage like this one. So starting from the magnetic tapes, anyone who ever used the magnetic tapes to save the data? My first computer was the Apple computer in 1983. I paid not me, my dad paid several months of his the salary, really. I still do not understand. Couldn't understand why he purchased such a very, very expensive computer to me. But anyway, at the time, to save the data, I need to use either, because hard disk drive is very, very small, okay, less than several megabytes. So I cannot keep all the data in the hard disk drive. Instead, I need to save the data 5.25 inch floppy disk drive. You know this size, the floppy disk drive. Either this one or magnetic tape, like the music tape you use. You know the cassette tape? I don't think usually nowadays anybody uses. Even in the cassette tape, you can save the data. That's the magnetic tape. Still used. Where? Backup, as a backup device. So magnetic 8mm, the backup tape is a still. It's called the dot tape. So still used. Why? Cheap. Sometimes more reliable than hard disk drive. For example, hard disk drive. How hard disk drive is organized? It has a disk, like the CD-ROM, your CD-ROM. Even nowadays, CD-ROM is not used. The CD-ROM, and there's a disk arm. So disk arm is moving forward and backward to read the data, and the hard disk is rotating to find the exact location. Which means, if just in case the disk arm, at the tip of the disk arm, there is the little tiny head. If that touch the surface of the disk, it's called a scratch. In case of scratch, it's a bad sector, you cannot read the data. You lose the data. There is a way to recover, but you may lose such a data. For example, recently I tried to open the image that the photo that I took almost 15 years ago. It's the first digital camera, so to take that photo. But I realized that some of the files are damaged because of the scratch of the hard disk drive. It's easily scratched. But magnetic tape, it's cheap and still reliable, even though you throw away. It's still data is there, unless there is a magnet. So this one is still used. Then going upward, which means faster. Okay, but problem is it's expensive. Okay, so register is the smallest one. It's the education nowadays. It's in the 4 megabyte, 8 megabyte usually. It's used for the cache, so it's a storage. And nowadays the solid state disk is still based on the memory, but without power, still they can keep the data forever. Actually, not forever. So several hundred years later, the data in the solid state disk will be gone. But nobody live longer than several hundred years, so it's maybe okay. So you don't have to worry about it. And the hard disk drive and optic disk, we expect popular media to store the data, but nowadays not many. The computer use optic disk. So this is the storage hierarchy. So then it's cheaper, faster, but expensive. It's faster, but it's expensive. Okay, that's the characteristic of our storage. So we will learn at the end of the semester more about the storage and I/O devices. Why do we have such a many different types of the storage device? Because it's cheap, so we can keep more data, but slower. So how can we overcome such a problem? Using cache. Okay, cache used a lot. So to overcome speed problem. I have a question. What is the difference between cache and buffer? It's a very frequently asked question when you have an interview. So what is the buffer and what is the cache?
Cache stores the recently visited data,
Mm-hmm.
and buffer stores the coming data.
So both of them, common thing is both of the cache and the buffer try to address the problem of speed, right? However, cache use previous data, reuse. For example, in the database system, when you are using, because my expertise on the database and operating system are very close. Because nowadays the database is getting important, so sometimes the database take over some of the job of operating system. That's what Oracle tried to do. The Oracle company would like to build a database operating system, which was failed. But this is true, very close. So in the database, what is the main purpose of a database? Several students already took my course in the morning. Store the data. You can store the data without database. speed?
Yes.
When you have a very large, huge amount of data, not easy to manage, right? So to manage the very large data, we need the database system. However, when you find the data, it takes a long time. You don't want to use such a database system, right? So we need to speed up to search it, to find the data using database. What is the best way to speed up to search the data? Indexing is one of the way, right? So just like the textbook you have, so you can use the index at the end of a textbook to find the specific keyword. Another way is caching. Caching, just like the memory. What is the purpose of memory? We can keep the data, all the data, no, needed data to the memory. Then you can use the memory as the cache area. Just like that, in the database system, we put the data from hard disk drive to the memory. If that is read, then maybe higher chance to be reused. If somebody, that's true. If you see any web application, it will be based on the click. Log on. When you log on, so when you click the log on button, it will direct to the database and customer username and password table. That will be used every time whenever user is trying to log on. So why don't we keep such a data in the memory? That is a buffer cache and that is a cache. So we can use such a cache for reuse. What about the buffer? For example, when you watch a movie, NFL live streaming or the soccer game streaming, so bandwidth require 1 megabyte. Okay, 1 MB the speed, but my network is 512 KB, so it's still slower. So it will be delayed, right? Instead, why don't we keep the intermediate? So some area is called a buffer. We store the data, but we don't start to the display until we satisfy the fill of such the in-between area. That is called buffer. Higher bandwidth, lower bandwidth. Also the buffer, you can see the example of buffer in the highway. So sometimes you can see something, the yellow box that has the water or the sand inside. So in case you hit the sideway or the lamp, actually buffer will reduce such a speed, high speed to the, then reduce the speed and for the low impact. So that is the buffer. So computer I/O devices use caching, right? The technique a lot to reduce the speed again. And buffer will be used for several ways, but the network slightly different concept. Also, when we read the data from the I/O devices to the CPU, anyway, you need to go through the operating system, right? Because you need to interrupt. When you read the data, certain sector of the data from hard disk drive, you need to interrupt and inform to the operating system, send the data to the memory. Then we have the sector and another block of the data, send it. Whenever you send a data, like why don't you think about the 1 gigabyte size file, the movie file. So how many interrupt? It's too many interrupt. That's the overhead. Because your operating system, your CPU stop every time. So instead, to speed up such a read the data, we can use, why don't we ignore such an interrupt? Bypass all the operating system mechanism. Instead, just directly send the data to the memory. That's called the direct memory access. So that is the most popular approach to speed up the performance of the operating system nowadays. So for example, from the device to the memory, you don't have to interrupt data and request and data. First time you can do that, then later it will directly send the data to the memory. the DMA is nowadays used a lot in modern operating system. In terms of the CPU, nowadays many of the CPU are based on the multi-core system and multiprocessor system, okay? Which makes us more crazy. So when we have the single core, the processor is much simpler, but because of the multi-core and the multiprocessor, it will be the more complicated, but mostly in this class we will discuss about the single core and the single thread. We will discuss about the thread, multi-thread, about the single core and the single processor operating system. However, in the multiprocessor and the multi-core system, we can think about the different mechanisms like the parallel system. Parallel system is the shared nothing. So each CPU and the memory and the hard disk drive, act the one separate node. Then we can get the parallel. To do that, we should have the parallel programming that can be separated logically. However, sometimes we can share the memory information because memory, as we have discussed, is the cache area. So CPU 1 is CPU 1 update the data for data item A, but if that is the parallel processing, the shared nothing, the other CPU 2 cannot use the update the data of A. So to address that problem, we can share the memory data. That's called the tightly coupled system. Problem? Very, very complicated and not easy. Sometimes it's slower because it's not like they can share the memory, unlike the multi-core system. If you have the separate device, you need to connect each and every device. So using memory channel or very high speed cable, the optic cable, even sometimes the optic cable is not enough bandwidth. So very expensive, and like the memory channel, you can connect them. Frequently, whenever data is updated, you need to apply, synchronize each other. It's much, much more complicated and overhead, sometimes slower system. Okay, so ideally we can do the tightly coupled system, which is not logically easy to implement, and everything should be changing. Okay, so that is the multi-core and system. There are two types. Okay, so this is the symmetric multiprocessing architecture. Okay, it has their own register and cache area register, but they are sharing the symmetry. So there's no difference. So user a user doesn't have to worry about which CPU will be used. Okay, so logically it's the same thing. So that's called the symmetric, the multiple architecture. So it's called SMP. So when you heard about SMP, symmetric multiprocessor, the processor means, so even though you have the multiple processor, multiple CPU, but from the user level, you don't have to worry about, you don't recognize which the CPU is using. Instead, the operating system is in charge of them. So what is the difference between the multiprocessor, like this one, and multi-core? Multi-core actually implemented in the same chip. Okay? On the other hand, the multiprocessor is a different chip. You can make the slot. One CPU, second CPU, third CPU. But in the multi-core, the system multi-core processor, each one, this core and this part act as the same. It will process one thread of the instruction. However, they are in the same chip, which means you can reduce a lot of overhead because they are accessing the same memory. However, your operating system should be able to handle and manage such a multi-core. Nowadays, most of the operating system they support the multi-core system. So in terms of user level, it's a symmetric level. So you don't have to worry about which one will be used. However, to get the full benefit of the multi-core the system, you need to actually consider in your programming to the segment your job. It's modular. It's called the modular, so you need to define the different. So if you are taking the parallel processing, what's the name of the course? Parallel programming?
Parallel and distributed.
Yeah, parallel and distributed programming. First, you need to design to get the full benefit. Or if you want to just use that operating system, you don't have to worry about it. You can just make the program just like the single core, single processor program. However, to get the full benefit of the multi-core, you need to think about the modularity from the design level. Still hard. Because of that, nowadays, the big data system would like to hide all the housekeeping work for the parallel processing in the application level, which means you can just implement your algorithm. Then the head-up system will distribute all the job, even along the node and the balance, considering balance, then to get the full benefit of parallelism. Okay, so that is nowadays the new technology. Because of that, so it's much more attractive. What about the cluster system? I mentioned about the big data system is kind of the cluster system. Cluster system means so by no matter what type of the tightly coupled or the shared nothing architecture, but anyway, using the multiple computer, a number of computer, we build one system, like the group system, cluster system. This is called the cluster system. So sometimes it's called the high performance computing. Several years ago, in my I offered the distributed database system class several years ago, but nowadays I don't have to because of the Hadoop, the big data system. But at that time, we implemented distributed the cluster system using PS3, PlayStation 3. So I think that you can still find a couple of the poster that implement the high performance computing using PlayStation 3. Are you using PlayStation 3, PS3, or PS4? Anyone? Gaming console? You use PlayStation or yeah. So PlayStation 3. What is that? What is a gaming console? It's a computer also. So exactly same thing. Nothing different, really. It's the same thing, but specialized for gaming, like the high performance for graphic card and not much memory, but the CPU power. So PlayStation actually work with the IBM and I think the Toshiba. I'm not sure. The power chip developed the power chip is 8-core. The CPU very fast, still the faster the processor CPU it has. So it's an 8-core. Why don't we use? So how much is it? PlayStation 3 at the time? It's just less than $300. So if I purchase the 10 PlayStation 3, how many core? 80 core. Really? So how much is it? It's less than $3,000. Less than $3,000, we can build the 80 core high performance computing. At that time, using the Fedora, the OS, we can build the cluster system. Then our goal is to develop the distributed database. So we install the MySQL distributed database. Then we can, when we submit the one application, which means the SQL, structured query language, is distributed by 64. So fast. Using the game console. Unfortunately, you cannot do that nowadays. Why? The Sony block for user to install other operating system. So you can use only the PlayStation 3, the operating system. If you want, you can come by my office, then I can let you use. I still use the old PS3 where you can install any the operating system. You can install the Ubuntu, you can install the CentOS, the Fedora operating system. Anyway, this is a cluster system. usually mostly for high. It needs to support high availability. HA means, what if I'm running the 10 computer, 10 PlayStation 3, then one of them is a fail. Do I need to stop all the system and fix it and running again? No, that's not good for such a, it takes a long time and too much recovery time. Okay, it's a waste of money, waste of time in real project. So instead, high availability means in case of fail, still let it process. Okay? Then the application level or component level should be recoverable. So that is the high availability. This high availability is implemented very nicely in the Hadoop system. So whenever I have a time, I'd like to introduce such a high availability in the Hadoop system. So they can use the storage area network. What is the storage area network? It's called the SAN. I think that you heard about the SAN before. What is the SAN? Storage area network. It's already done? Let me know. Sometimes I forgot the ending time. Okay. So what is a storage area network? So network for storage. So idea is, why don't we have the one big storage machine instead of the local storage? Then we can share the data even along the computer. That's a nice idea. Problem? This one. Connect. It should be fast, right? In the local, it's fast. Why? Because you can use the bus, I/O bus in your computer, so you don't have to worry about the speed. But when you have the external hard disk drive to be shared, it's a problem. So, however, we have the very fast the media like the fiber optics. So fiber optic is pretty much fast enough. Each computer cannot recognize whether this is a remote or not. So we can build something network topology for cluster computing. That is called the storage area network. Nowadays, it's a very, it's not popular, it's everything. Most of the IT company and enterprise level, the IT environment, they use the storage area network. Even this storage can be accessed as another computer, another node. Yes?
Is this what we use at UV as well?
I don't know yet. I don't think so. Yeah, because when I had a meeting a couple of years ago for my project, they do not have the storage area network because it's relatively still small. But I heard that the UV IT the department improved a lot of facility. So maybe if they purchase the storage box like the EMC, so EMC is one of the popular IT company who provide the storage solution. Very nice. The benefit for the employee, and one of my close friends works for the employee at the EMC. Their salary is so good and very nice. Sometimes the EMC company invite all their employees worldwide all together in one area, really. Then to have a party. But I don't know yet nowadays, but they did long time before. So that is a cluster system. Okay. So far we have seen the overview and review of such a computing architecture and what about the operating system? A long time ago, which operating system is the oldest one for your experience?
95 probably.
Windows?
95.
And anyone who used the MS-DOS?
DOS
Yeah,
12.
MS-DOS, right?
MS-DOS.
So MS-DOS is a it's a operating system in Microsoft. Actually, when Bill Gates developed the first computer, in his garage, he modified and make the MS-DOS. Problem?
Command line. No graphics.
MS-DOS actually support one program, one job at a time.
Right.
Is there any operating system that supports the one? Yes, still exists, the embedded OS. So small device, you don't need multiple job, multiple process, only one is enough, like the MS-DOS long time ago. So to address that problem, why don't we support the operating system multiple programming? So that is the multiple programming characteristic of the operating system, like the job 1, job 2, job 3, job 4. And when you have the 512 megabyte the memory, so you can support the multiple programming. What about the multitasking? Time sharing, multitasking. What is the difference? What is this? I need to attend the meeting. This requires. So what time is it? Do I need to? I don't know. Fired if I do not attend. But anyway, time sharing. What is the time sharing? Time sharing means, as the name implies, we slice the time. For what? To run the process at the same time. So looks like the multiple processes are running concurrently. However, it's not the real. It looks like it pretends, but actually we have only one timeline per CPU. Then we chop, slice, then interact the in and out, a lot of in and out. That is called CPU scheduling. Wow, how? So we cannot increase the real CPU time. CPU time is fixed like our time, okay? But we can get the better performance using the multitasking. Why? We wanna maximize the CPU utilization by sharing. For example, when you read the data from hard disk drive, what CPU can do? No, nothing. CPU must wait until the disk controller interrupt. Until disk controller receive the data from hard disk drive. Okay? During that time, nothing you can do. Why don't we use this waiting time for other process? That is the idea of the time sharing. Then we can get the higher response time. We will say what is the response time later. Okay? By the way, after MS-DOS, DOS, Bill Gates developed Windows by adding the nice fancy interface. So 3.1 was my first the Windows program, a Windows operating system. Problem? There are two operating systems in one. MS-DOS, DOS, and Windows. That's a huge problem, actually. So because of that, Microsoft need to decide which one will be gone. So they finally decide the MS-DOS no longer exists. Instead, sometimes you can see the similar interface. It's just command line interface. Okay? It's the same as Windows. It's not MS-DOS. But many people love to use the command line interface. So like the Unix and Linux system, Windows 10 include PowerShell, even the shell programming for using the command line interface. Okay, so this is the multi-programming system. Okay, even this operating system is an interrupt-based interrupt-driven. So it uses a lot of software interrupt because the operating system serves the software. Okay. There's another operation which is very important in the operating system, dual mode system. Dual mode system means, so there are applications, okay? As we discussed earlier of this class, so when you read the data from Java programming, do you use the read system code or system library? No. Inside the Java, yes, probably, but outside, you don't use. So eventually, no matter what types of application you use, that application will call the system library, system call. Who is in charge of that system, operating system? Also, it's very important. You should have the most of the permission to access the hardware and the devices. So if you give the permission to the end user, it will be serious problem. Like it can be hole of your security. So operating system has the two different modes. One is user mode, user process mode. Another one is kernel mode. So anything that can be run the user processor. However, in case user need to access, user need to use the system call, system library, built-in function in operating system, the kernel, your operating system will take over the ownership, that part. Then user process your application program will wait until this system call is, actually even though you call, system library, that doesn't mean you can directly use that system call. You do not have permission, okay? Operating system will not give the permission. Instead, ask to the kernel, then kernel will process. It's another thread of the processing. That is a reason. Sometimes when you monitor your operating system, you will see how much usage of CPU by user mode, and system mode. It should be balanced. So why the 100% utilization is the problem? When you check the task manager or any monitoring tool, if you are using 100% of the CPU, your system may not running correctly. Why is the problem?
Global stack integrate.
Because kernel cannot have a chance to process this one, which means it's usually 100% will be happened by infinite loop while without condition, right? Because of the usage of 100% usage of user process, the kernel cannot process more important the job. Okay, so it should be balanced. Sometimes somebody said 3 to 1 or 2 to 1 the balance. Okay, which means nowadays the user part is getting higher, then kernel part is still the same level. Okay, so this is the user mode and kernel mode. So, do I have the time? Okay, so I think then from next week we will see the more in the operating system concept. Then from the third week we will start from the process management. So I think I can quickly jump this part that we are going to discuss from the week after. Okay, so this is a process management. Then the memory management and storage management is the overview of the entire semester, I/O management, and so on. So next class, I'm going to briefly introduce about the computing environment nowadays. Nowadays, computing environment is changed a lot, like the mobile environment, clouding computing, and so I will introduce a little bit about the computing environment. Then we continue the chapter 2, and the next week, the Wednesday, we will have the first exercise lab in this room. At the time, why don't you bring your own device, and before you come to here, why don't you download and be ready to use the virtual machine. Okay? Any question? Thanks so much, and have a great weekend. So we will see you on Monday.